Good morning, children. Today we are going to see the second portion of our lesson number 4, which is atomic structure. We have already seen the structure of an atom in the first class, is it not? Atom contains electrons, protons, and neutrons. Electrons are the negatively charged particles, protons positively charged, and neutrons are neutrally charged particles. And they electrons revolve in the shells, and the shells were numbered 1, 2, 3, and they were named as KLM, is it not? Now we are going to see what is a ion. Ion means, actually, in nature the atom is always neutral. Neutral means the number of protons will always be equal to the number of electrons. That is, the positive charge will be equalized by the negative charge. Then, during chemical reactions, that is, when one element is getting reacted or combining with another element, it donates or accepts electrons. Donate means what? Give away. Accept means, to take it inside. So it will donate or accept electrons according to the reactions. Okay, according to this, we can say the atom that attains the negative or a positive charge is called as ion. So what is ion? The atom with negative or positive charge. Okay, but in nature or in a stable condition, the atom is always neutral. So neutral means the number of positive charges will always be equal to the number of negative charges. But during reactions, there will be loss of electrons or gain of electrons. Loss means we are going to donate the electrons. Gain means we are going to accept the electrons. Accordingly, the atom will have a positive charge or the negative charge. So the charged atom or the atom with negative or positive charge is called as ion. Now we have two types of ions. One is cation and the second one is anion. Cation and anion. This is what happens. The neutral atom is in green color. When the loss of electrons will happen, that means you are giving away the negative. Electron means negatively charged particles. So you are giving away the negative. So the atom will become positive. So that is why cation is positive. Now, when I'm going to accept more electrons, means electrons, we have already told, negatively charged particles. So when I accept more negatively charged particles, the atom will become negative. So that is called anion. We are going to discuss the properties. Cations, an atom that loses or donates electrons that and attains positive charge. So cations means an atom that loses or donates electrons and then it will attain the positive charge. We have the example of calcium. Calcium will lose 2 electrons, that is why it is written as 2 plus. That is, there is a positive charge in the two electrons which we have donated will be equal to the 2 positive charge. So that is Ca 2 plus. And for potassium, K stands for potassium. So potassium, it will be giving only 1 electron. So only we are having only 1 positive charge. So what is a cation? An atom that loses or donates electrons and it will attain positive charge. So cation means it will have positive charge, or you can say positively charged ions are called cations. Now coming to anions, it is the opposite of cation. So anion is an atom which gains electrons, and so it will become negatively charged ion. Here we have given the example of oxygen and sulfur. Oxygen, it will gain it will gain or accept 2 electrons. So it is 2 minus electrons are gained. So that is why it is electrons negatively charged. So we are gaining the electrons. So it is mentioned as 2 minus. Similarly for sulfur also we are gaining 2 more electrons. So that will become 2 minus. Coming to the radicals. Radicals, we are not going to talk about elements. So 2 or 3 elements when the ionic stage will combine, so that will become radical. So an atom or a group of atoms, we can say group of atoms of different elements, different elements will behave as a single unit. It can carry positive or negative charge and they cannot exist independently. They have to combine with another element or according to the reaction. So the two types of radicals, we have simple radicals and other one is the compound radicals. Now, what is simple radicals? It is only made up of one kind of atoms. It is only made up of one kind of, like our magnesium, which is only two atoms of magnesium, or you can say two electrons are given away. So you get two positively charged uh, protons, or it is then coming to the oxygen, we are giving or we are gaining 2 electrons more, so that is 2 negatively charged electrons are gained, so that is why it is 2 minus. So it will be simple radicals, or in this case we are having compound radicals. Compound radicals, we are going to have 2 or more kinds of atoms. Look at the example. We have given nitrous oxide, or you can say nitrate, and then there is one carbonate. It is called carbonate, and then first one is called nitrate. Nitrate, you have N, that is nitrogen, and you have 2 atoms of oxygen. And here in carbonate you have 1 atom of carbon, 3 atoms of oxygen. Okay, and accordingly their charges. So this totally they behave as a unit. Okay, this carbonate within that whole bracket we say, so they behave as a single unit and they cannot exist independently. They have to combine with other elements. Okay, we have calcium carbonate, we have sodium carbonate, all this, because carbonate as such cannot exist independently. So carbonate CO3 it is 2 minus, so it is having a charge of negative charge of 2 electrons. Okay, now coming to the radicals definition again. So what is radicals? It is the atom or group of atoms of different elements that behave as a single unit, like in the case which we discussed as carbonate, CO3. So carbon is one atom, oxygen is another element, and that 3 units of oxygen is combining. So totally we have 4 atoms combined to form the single unit called carbonate. Then it carries positive negative charge. Okay, it will carry a positive or negative charge and they cannot exist independently. Okay, these 3 points you have to remember, and with the example of the compound radicals. Now coming to the periodic table. Periodic table, what do you mean by table? Table is a chart, okay, which will tell about the number of elements that exist in the world. That is, we have so many elements. How many elements we have? We have 118 elements. How many elements? 118 elements. Okay, now we have to arrange them in one manner. So we are now using this modern periodic table. We are using the periodic table. The name of that periodic table is modern periodic table. In this periodic table, we will be having 118 elements. And how are they arranged? They are not arranged in alphabetical order. They are not arranged on based on metallic properties. No, they are arranged based on the atomic number. Atomic number means the number of electrons present in it. it is the number of electrons. It is based upon the number of electrons of each element. Okay, now in the table, okay, table you can think of like our rows and the columns. No, so the horizontal rows are called periods. The rows are called periods. The vertical columns are called as groups. The vertical columns are called as groups. So we have 7 groups, 7 periods and 18 groups. We have 7 periods and 18 groups. So the number of shells decide the period number. The number of shells, how many shells or the orbits will decide the period number, and the number of valence electron will decide the group number. Period number is what? The row number. How many rows we have, first row, second row and all. How we are going to decide? It will decide on the number of shells. One shell, the first shell, second shell, third shell. Now, how will you decide the group number? In the same way, we will consider the number of valence electrons to decide the group number. So what is a periodic table which we are using now? We are using the modern periodic table. Okay, why we want a periodic table? To arrange the elements present in the world. Okay, either they will be naturally occurring elements, or we can create the elements in the laboratories also. Okay, now how are we going to arrange the elements? We are going to arrange the elements based on their atomic number. Okay, what is atomic number? Atomic number means number of electrons. Number of electrons. Okay, now in the table, horizontal rows are called periods, and the vertical columns are called as groups. So how many groups and how many periods we have? We have 7 periods and 18 groups. Now how are we going to decide the period number and group number? Okay, that which row we want to select or which column we want to select. So the rows are decided upon the number of orbitals or number of shells. Now coming to the uh, group number. The group number is decided upon the number of valence electrons. This is how your periodic table will look like. Now count how many rows we have. 1, 2, 3, 4, 5, 6, 7. We have 7 rows. How many columns we have? 1, 2, 3, 4. If you count, you will be having 2, 3, 4, 5, 6, 7, 8, 9, 10. You will be having 18 columns. Similar way, the first row, you have only 2 elements. One is hydrogen, second one is the helium. At the last end you see, that is the helium. Now what is 3? It is the lithium. Okay, 4 is beryllium. Fifth one is the boron. Sixth is carbon. Seventh, nitrogen. Eighth is oxygen. Ninth is fluorine. Tenth is neon. Okay, now the last column. Okay, last column, the helium, neon, argon, krypton, xenon, they are called as rare gases or rare elements. Okay, or inert gases, because they will not react at all. They will not chemically react at all, because they are highly stable. They are highly stable. They will not get into any reaction. So we will not be talking about those inert elements at all in chemical reaction. Now, so from the first column till the fluorine column, that is still the column before our inert gas column, only those elements are available for chemical reaction. And then we have 2 rows in the bottom, starting from 57 to 71 and 89 to 103. What is that? They are called lanthanides and actinides, which you'll be learning in the next year in the 8th standard. So as of now, you will be having this periodic table with 118 elements. See, the last element number is 118. okay, which will have 7 rows, 18 columns. Rows are called groups, and columns are called periods, and we have to know this much as for the periodic table in your 7th standard. Now, what are the valence electrons? We know the electrons or the free electrons which are available in the outermost shell of an atom, okay, which are available for reaction. So, those free electrons will decide the group number. Okay, now in boron we have 3 valence electrons. So, the boron is placed in group number 3. See, boron, it is the symbol is capital B, so it is there in group number 3. So lithium, beryllium, first group, second group is beryllium, third group will start with boron. Okay. Now aluminium. Aluminium also will have 3 valence electrons, so it is also placed below boron. Okay. Coming to oxygen, it will have 6 valence electrons. Okay. So it is placed in the 6th column. Okay. 1, 2, 3, 4, 5, 6. So already we have placed the boron. Now after boron you will have to move 3 more columns, so that will give you the oxygen. Coming to fluorine, fluorine has 7 electrons, so it will be placed next to oxygen. Then silicon, it is having 4, so it is placed next to boron, where boron has 3 valence electrons, and silicon, carbon, everybody will have 4 valence electrons, so they are placed under the same column. Then you have phosphorus with 5 valence electrons. You have phosphorus, nitrogen, all this and in the same column. Okay, so the valence electrons will decide the group number. The number of valence electrons will decide the group number. Okay, so you have to go through this video slowly, understand, and then you have to answer these questions. Okay, thank you.